Hello. I'm very excited to be speaking to you folks. I have, as Zane introduced me, my name is Finbarr, for those of you I didn't get a chance to meet last night. I'm I write an independent newsletter called Artificial Fintelligence, and as you might be able to tell from the terrible pun in the title, I'm also a father, just like Zane. And so today I'm going to be talking to you about the state of AI. And I'm going to be talking through kind of what's happened in the last year where we've seen this seismic shift in technology and where I think things are going to be going. I'm going to start off by talking about a brief history of GPTs, which are the model that has captured the tech industry. And okay, so what is a GPT, this arcane acronym? And so what it stands for is a generative pre-trained transform. And so generative means that it's able to generate media, whether that's text or images. Pre-trained means that it's trained on a wide variety of data to accomplish a broad array of tasks, rather than the kind of pre-existing paradigm where you'd have a specific data set, you train a model to accomplish a specific task. We're moving towards this general, these very general models, and a transformer is just a type of neural network. And you may be wondering, why am I telling you about this? Why am I, teaching you what this acronym stands for? And the reason is just that it works very, very well. And so what we're seeing is that we're now at a point where computers are able to actually engage with text and with language as a first-class input. We're actually able to have computers engage with semantic understanding of text, and we're no longer restricted to just mouse and keyboard or tapping interactions. We're able to speak with them or exchange prompts with them. Okay. So if we go back to, this is Prometheus bringing fire to man as imagined by Midjourney. And so if we go back to GPT, which is this metaphorical fire that has been brought to us. If we look at I want to walk you through the timeline because I think it's really informative on what exactly is going on here and what the future will bring. And so what we see is that the first GPT model was brought to us in 2018, introduced by a paper from OpenAI, and they had a model with 120 million parameters. And they trained it on a data set with 20 million tokens. You don't need to know what a token is. It's just the unit of measure we use to say how big a data set is. If you think of it as a character, like a letter or number, that's not accurate, but it's close enough for the purposes of this talk. And they had a specific architecture, which is I'm not going to go into detail. They then introduced GPT-2, which was the successor, in the following year. And the major change that they made, really the only major change that they made, was to dramatically increase the scale. So they went from 120 million parameter model to a 1.5 billion parameter model, a 10x increase in model size. And the data set increased by, what is that, a 450x increase. And they slightly tweaked the model, but really the change was just in the size of the model and the data set. And it produced a really incredible increase in performance. And then when they moved to GPT-3 in 2020, they repeated the exact same playbook. They went from a 1.5 billion parameter model, they made it 100 times bigger to this 175 billion parameter model, and they increased the data set by another factor of 30x to 300 billion tokens. And they tweaked the model a bit, but they didn't make any substantial changes. The real advance was just making the model bigger. And then this was then used in 2022 to make ChatGPT, which is one of the fastest growing products in history. They just took GPT-3 and they made some tweaks to it. What's really remarkable here is, and I really want to hammer in on this, the difference that happened in all of this technology was scale. They made the model, going from the first GPT paper to the third one. The change was a 1,500x increase in model size and a 15,000x increase in data set size. The change was scale. There was not any fundamental scientific advance that was discovered. They just made it bigger. And we're at a VC conference, or a conference hosted by a VC, and so you might be asking, how did they justify this investment? Because if you're increasing something by 3 to 4 orders of magnitude, that's expensive. And each of these runs, for GPT-3 is estimated to cost, just for the compute alone, is about $5 million. And that's not counting the cost to scrape and process data, have the highly paid researchers write the code. And even once you've raised the money, it's not just a matter of going to AWS and saying, okay, here's my credit card, take all my money. You actually have to build out a custom data center to do this stuff. It requires very specialized hardware. And so the question is, how did they justify this? What they did is they developed scaling laws. And so this is Archimedes in the bathtub, discovering displacement. And so what they did is that they asked the question, can we predict model performance? Can we learn a model that will predict how well our other models do? And it turns out you can, and it does quite well. And so what the folks at OpenAI, and then later some of my former colleagues at DeepMind did, is they just trained a large number of models, and they learned the performance characteristics of these models. And they used that information to be able to predict how these models behave as you dramatically increase the amount of compute and the amount of data that you give it. And what was really, and so they came up with these curves that we see here. And what was really remarkable is that as the models get bigger, they become more efficient. And so you require less data with a bigger model to reach the same level of performance. It's much more efficient. And so what that means is that you have an incentive to create the biggest possible model. So as a result, the large research labs all went out, they saw that, and they immediately went out and they raised an incredible amount of money. And actually this is out of date, because in the last week we've seen Anthropic, I think, raise another, I think they're up to $4 billion now. And so there's just this incredible amount of money that's flowing in, because the paradigm is such that the biggest model is by far the best and it's more efficient. And so the best thing you can do is just take all of your money, go buy a bunch of GPUs, go get a lot of data, and train the biggest possible model. And so there's this massive competition to be the company, the research lab with the biggest model. And so we see, Anthropic has, now $4 billion. They're rumored to have 100,000 of these H100 chips. DeepMind is supposed to have, 60,000 of their in-house equivalents. Inflection, started by one of the DeepMind co-founders, they have this 1.3 billion. And even a company like Imbue, which was, relatively less known, they raised, this 200 million round, and they have this incredible amount of chips. And it's this place where there's just all of this investment is flowing into this competition to see who has the best model. I know if any of you, hopefully everyone here is a long-time NVIDIA bag holder, because that's, the main beneficiary of this. But kind of the natural question to ask is this a bubble? And so, what we're starting to see at the top end is valuations are getting around the 100x ARR level. And that's not even the worst of it, because we're also seeing companies with incredible valuations that don't have revenue. So they have an infinite ARR multiple. I'm a student of history, and so if we look at some past bubbles, I think they're informative. So if we look at what I think is the most interesting historical bubble is, of course, the Dutch tulip bubble. The difference between that and I think what we're seeing now and what we've seen more recently is that there is significant value being created. Like if we look, OpenAI is rumored to have over $1 billion of ARR. That's up from, again, the rumor is 13 million the year prior, so they had a 100x increase. There is value being created. And so, to the extent that there is a bubble, I think that what we're seeing is that it's more in the pricing, but there is still value being created. Maybe the analogy is the dot-com bubble, where there was significant value being created, but there was also unsustainable activity. The other thing that's messing with valuations is that there's a lot of self-dealing, where you have companies that are raising money from the vendors that they're about to give all the money to. And so NVIDIA, for instance, was behind most of the investment in Inflection. And so they turn around and they take all of that money and they give it back to NVIDIA to go buy chips. And so a lot of these valuations are perhaps not the same as if Relay had gone out and written a big check, because the money is, the margin, it's a very different cost structure. Okay, so I'm now going to commit the sin of all speakers where I try to predict what's going to happen. And we have, this is supposed to be the Oracle at Delphi. I don't think it's at all accurate, but it's a pretty picture. So I think the biggest thing that we're going to start seeing, I think, in the short term in AI is there's a massive emphasis among practitioners on efficiency. And so everyone is, all the companies are going out and raising incredible amounts of money and sky-high valuations, and then they're not doing a very good job actually using these chips that they have paid so much money for. And so you see, at the lower end, the less effective labs are maybe around 10 to 20% utilization, and the best ones are around 60%. I think we're going to see convergence here. I think we're going to start seeing the less efficient labs start pushing those numbers up. And what that's going to mean is that costs are going to start to go down, and we're going to start seeing just improvement on speed and performance there. There's just generally across the industry, there's incredible cost pressure on every levels of the stack, because it is so expensive to work with these large models. And an interesting trend that we're seeing is we're seeing these highly paid researchers, we're seeing people move out of these senior management positions, maybe director level or VP level people at the big tech companies are now moving into individual contributor roles where they're actually writing code again, because they're so expensive that you can't actually hire a lot of these people, and so you need to have them moving in these roles. And so I think we're going to see stuff like that continuing. On the hardware side, we're going to continue to see massive improvements, incremental improvements here in the next-gen hardware. I think that the biggest driver, one of the biggest drivers of costs, is that NVIDIA has a complete stranglehold on the chips that everyone's using. Everyone uses NVIDIA chips because the CUDA software is so good. I think that moat is looking very vulnerable right now. And so, the promise of the last few years, which might come to fruition now, is that custom chips are going to start coming along. They offer, first of all, these massive performance improvements if we can specialize the hardware to these dedicated transformer architectures. But there's also just the potential for cost. And so, if Google's ever able to, offer a strong consumer product with the TPUs, or we see the terribly named AWS custom chips, we're broadly seeing opportunities for margins to come significantly down, and again, prices to start dropping when we start looking at serving these and training these models. Generally, as Alex kind of gave the doom and gloom opening, we're also seeing, AI has been maybe the one bright spot where valuations have been very high. Again, we're seeing some 100x ARR deals happening, but the broader venture ecosystem isn't great. Public market comparisons aren't doing great, other than the biggest companies. And so it's really hard to imagine that the current paradigm is going to exist forever. We're seeing AI salaries are very great, which I'm quite enjoying, but I don't think it's sustainable in the long term. And so I think what we're going to start seeing is a lot of consolidation of the industry, whether through mergers and acquisitions or unfortunately just shutdowns happening. But that is not all. Well, that's incredibly unfortunate for the companies that it might happen to. The broad story in AI over the last year has been one of chip availability being a major limiting factor. There's an apocryphal quote from Picasso, where he said that when bankers meet, they talk of art, but when artists meet, they talk of where you can find cheap turpentine. And that's been true among AI researchers, where when some of us get together, what we're talking about is, who has chips and where can we get some for ourselves. And it's just been incredibly difficult and expensive to actually get state-of-the-art chips that work properly. The company that provides them, which is Mellanox, they provide the InfiniBand hardware that's used by the NVIDIA clusters. They've had a lot of supply chain issues, and they just started looking like they were getting resolved. And they're an Israeli company, so with the conflict happening there, they've encountered a number of difficulties, and so it looks like that's going to be delayed even further. And for all of these large training and inference clusters, it's all requiring specialized data centers that are really built out to handle the power and networking requirements. It's not just a matter of going to Amazon and giving them your credit card. And so it's required all of these companies to go and you raise a bunch of money, and then you find someone, you sign a long-term commitment, and they build out this data center for you. And what that means is that if companies aren't able to keep the massive burn rates that we're seeing, all of a sudden there might be a lot of chips coming online in maybe the next 10 to 12 months as some of these companies start running through the amount of money that they've raised. And so it's kind of I would say one of the biggest questions that AI companies are facing right now is whether to sign these long-term commitments or to kind of hold on and hope that the market is going to completely change in the foreseeable future. And it's not just companies maybe going under and freeing up their allocations. There's just all of these competitors just streaming into the market. Like NVIDIA's had this incredible year, and so AMD, Intel, Graphcore, some of these startups are coming in and doing what they can to compete. And it's really difficult for me to imagine that the current state of the art will continue for the foreseeable future. But until then, we're stuck giving our pound of flesh to NVIDIA and funding Jensen Huang's next yacht. On the capability side, what I think we're really starting to see a lot of excitement around is voice. When I go down to talk to my friends in the Valley, everyone's really excited about the latest voice demos. I think we're going to be at a spot where already text-to-speech has gotten very, very good, and I think we're going to start seeing a lot of voice-first interfaces. I don't know how many of you use the ChatGPT voice interface, but it's quite impressive. I think there's going to be a lot of stuff coming out in the short term on that front. There's also a lot of attention on agents. That's where a lot of funding has been going into lately. A lot of really smart people working on this. That was what I worked on. Had DeepMind for the last 5 years, and it never really worked particularly well. So I'm a bit skeptical, but I think that is going to be explored really deeply. And then robotics. I mean, we saw with Promise. I mean, they have very exciting work, and there's a lot of very exciting demos that have been making the rounds. But it's not clear how many of them have actually made the transition to commercial applications. So again, that's really what I'm kind of keeping an eye on in the near term. Okay, and so then where is the research heading? Where are the researchers spending time? And this is, again, mid-journey imagining what Isaac Newton looked like when he discovered the laws of gravity. I don't know if that's entirely accurate. So again, just to keep hammering home cost, when you look at the GPT-3, it is a 175 billion parameter model, and what that means is that every time you have a character being fed through the model to generate a single output, it is doing 175 billion multiplications. And computers are fast, they're not that fast, and that's just an inherently expensive thing to do. And everyone, in the industry at every level of the stack, whether that's NVIDIA building the hardware, whether that's Meta and Google building the software layers that we run on, or the researchers working with the high-level code like myself, everyone is doing everything that you can to get the cost down and make it more affordable to run these models. And I expect we're going to see massive advances on that front. The other thing is that we're going to start seeing a lot of improvement when it comes to factual accuracy. You know, the models, what they're doing right now is they're predicting the next token or next character in a sequence. They have no notion of facts. to the model, Daenerys and from Game of Thrones is as real as Joe Biden. And so if you were out to ask, who won the American presidential election, all it knows is what's being said on the internet, right? It has no notion of factual accuracy. And so what I think we're going to see, and we are seeing this to an extent, is that these models are going to start using APIs. And so, I hopefully I consider myself reasonably to be reasonably good at math. I have 2 degrees in it, but I'm still very bad at arithmetic. And so, if I need to do some sort of calculation, I'll use a computer. I'll use a calculator. I'll use a tool to solve that. And I think we're going to start seeing that with our models. And if you actually look at what these models are trying to do, it's an incredibly difficult problem. And so if we have the very simple problem of 1 + 1 = 2, and we ask our model to solve this, what we're really trying to say is we have to convert this into numbers because these machine learning models are numerical models that operate on numbers. And so we convert it into this arcane sequence of integers that you can see there, right? And what we're really trying to do is we're trying to say, given the sequence 16, 489, 220, 16, 284, and 220, predict the number 17. And 17 here is the numerical representation of 2. This is using OpenAI's tokenizer, which is the process that converts text into numbers. And that's just an inherently difficult problem. There's no semantic meaning to that. And so it's a much easier problem to say, oh, wait a second, this looks like a math problem. Let's go throw it in a calculator and see what the answer is. And so, I think that's what we're really going to start seeing a lot of the solution being. The main distinguishing factor between us, humans, and other animals, I would argue, is our ability to use tools. And we want our models to be able to do this as well. And so we're going to be seeing a lot of work trying to incorporate tools into our models and trying to have our models, figure out how to, use computers and use other sorts of digital tools to augment their performance. The problem is that it's not really clear how to do this. The kind of paradigm is that you go and you pay a bunch of humans to generate a lot of data for you, and then you go and train on that data, but that's very expensive, and it's immediately out of date. So there's a lot of research focus that's focusing on trying to figure out how to do this in a cost-effective way so that we can adapt to new settings. That is my talk. I really appreciate you listening to me. Yeah.